9:47 on this Saturday morning. It is time now to imagine it with the chief scientist from the Imagination Station, Carl Nelson, whose only instruction to me was to not knock the big flaming thing off the table.
Exactly.
Good. Got it.
It is National Chemistry Week next week.
Oh, cool.
And at the Science Center, we're doing all sorts of stuff related to chemistry. And the theme this year is energy.
Sure.
Okay. And so, here, let me give you this. Just hold this for a second.
Okay. Is this potential energy?
Well, you know, we have heat energy here coming out of the flame.
Okay.
And chemists talk about this thing called heat capacity. It's sort of the ratio between how much heat energy you put in and then what the temperature change of the substance is.
Okay.
So we have air inside this balloon, and if we were to try to put it in the flame and heat the air up, the balloon would pop.
Kablamo.
And even blow out our flame.
Whoops.
But
don't
your
knock
balloon,
it on the floor.
yeah, don't knock it on the floor.
Right.
Your balloon, however, has water inside of it. Okay. It's got a little bit of water in the bottom.
Right.
So what I want you to do very carefully is lift the balloon up high.
Okay.
And then just bring that down right over the flame.
Well, this flies in the face of every notion you might have. So
just
I'm going to lower it slowly.
Try,
Am I going fast?
That's good. That's fine. Here,
How far down?
Here, I'll just
all
move
the way
flame.
up.
Look at that.
The flame is lapping at the bottom of this balloon.
Is hitting the bottom of the balloon. In fact, it'll even
Carl.
burst if we get to the side of the balloon that has no water inside of it.
Terrific.
So the water is a tremendous, a tremendous absorber of heat. Okay, and so let's try this again.
All right.
Okay, so we got some water in a paper cup. All right, now we could take this paper cup and actually stick it right here, put the flame below it, and we could even crank up the flame if we want, get it really hot.
Sure.
Or we could blow it out, or we could just resort to the blowtorch.
The big brulee.
And we can actually hit this cup of water with flame directly, and the cup's not going to catch on fire. The water inside is such a great absorber of heat. In fact, we can even hit the sides of the cup. Now, it chars a little bit because there's a little wax on the outside of the cup. In fact, if we wanted to, we could even ignite the top of the cup a little bit where there's no water.
A flaming cup of water.
But watch, though. As the top burns down, the flames are going to go away.
Here we go.
And we can continue to hit this with the flame. Again, the water is absorbing all that heat energy.
You're just trying to get me wet again.
No. In fact, you know what? Go ahead and stick your finger in the water.
It's like a dunk tank.
Is it
It's
warm?
warm, yeah, very warm.
Yeah, because the heat energy is warming that up.
Okay.
Now, other than popping balloons and cups that don't burn, why is this important? We live in the Great Lakes region. We have these huge reservoirs of water that help moderate our climate. Right, northern Michigan, you got all those microclimates up there for growing grapes and things like that.
The lake effect.
Lake effect snows, you get the cool breeze coming off the snow, all because of the tremendous heat capacity of water.
Excellent.
So probably should point out, don't try this at home.
Right, do not try this at home. All right,
You can see what happens.
Thanks very much, Carl. And I'm sure that Ross Ellett and all of our meteorologists can tell you more about the lake effect, but you can go down to the Imagination Station and try it out for yourself. Thanks again. We're going to turn it over now to Dave with sports.